the Bohr's theory. In our last class, we discussed about the energy of Bohr's theory. Energy of Bohr's theory is minus RCH z square by minus RCH z square by n square. That is the formula what we got. Energy of the Bohr's theory are minus RCH z square by n square. Energy when electron is revolving around the nucleus. This is the total energy formula we got. And now in today's class, we have to discuss about when there is a transition of electron from one orbit to another orbit. Transition of electron. So transition of electron from one orbit to another orbit. From one orbit to another orbit means what we'll observe there, the difference in energy delta E is equal to E2 minus E1. We know that when electron jump from higher energy level to lower energy level, it emits the radiation. From lower to higher, it absorbs the radiation. So a difference in the energy level, transition of electron from one orbit to another orbit means delta E is equal to E2 minus E1. So now, by taking this formula, delta E is equal to E2 minus E1. Here, E1 is minus RCH z square by N1 square. E2 is minus RCH z square by N2 square. So here E1, E2 we got. So delta E, what is delta E? Difference in energy levels. Difference in energy levels is E2 minus E1. E1 value, energy of electron in the orbit N1, energy of electron in orbit N2. Like that I can write. Here from this formula, what is delta E now means? Delta E is equal to, if I substitute that, I can write direct formula as RCH z square into 1 by N1 square minus 1 by N2 square. This is a continuation of previous topic. In the first page, I explained energy of electron in nth orbit. What I discussed in last class is minus RCH z square by n square. If transition of electron from one orbit to another orbit, then delta E can be written as E2 minus E1. So now, here what I did is delta E is equal to E2 minus E1. E1 value is minus RCH z square and 1 square. E2 value minus RCH z square and 2 square. Substituting these two things in the above formula and taking common RCH z square common, I can write the formula like that. Now, here what is the formula I can write? Delta E is equal to RCH z square into 1 by N1 square minus 1 by N2 square. From where did we get this one? Means from last expression here we got by substituting these two here in the formula. Here RCH z square I have taken common, so that I got the expression 1 by N1 square minus 1 by N2 square. Now in this page, I am taking this formula. This formula what we observed is, that is whenever there is a electron jumps from one orbit to another orbit, then the energy difference I can write it as RCH z square into 1 by N1 square minus 1 by N2 square. Now, whenever electron jumps from one orbit to another orbit, suppose higher to lower, it emits energy. It emits the energy means this energy is in the form of photon energy. So I can write delta A is equal to h mu. So h is what? Planck's constant. We know that h is Planck's constant. And here mu, what is mu means? Frequency of radiation. Frequency of radiation emitted. So substituting this one in the above formula, I can write h mu is equal to RCH z square into 1 by N1 square minus 1 by N2 square. Here h are cancel, so that I can write mu is equal to RCZ square 1 by n1 square minus 1 by n2 square. Is the formula for frequency of radiation is equal to RC z square into 1 by n1 square minus 1 by n2 square. So here delta E is difference in energy levels, and your frequency mu is frequency of the radiation. When it electron jumps from higher to lower, it emits the radiation, and the frequency of that radiation is mu. Mu formula is RC z square into 1 by n1 square minus 1 by n2 square. Now, taking this formula for mu is equal to, just now we derived RC z square into 1 by n1 square minus 1 by n2 square. I know that frequency can be written as C by lambda. C is speed of light in vacuum, speed of light in vacuum, and here lambda is wavelength of the radiation, wavelength of the radiation. So that I can write now the formula as C by lambda is equal to RC z square into 1 by n1 square minus 1 by n2 square. Observe carefully here. C common, they will be cancelled. So what is the term left here? 1 by lambda is equal to RZ square into 1 by n1 square minus 1 by n2 square. So this is the formula for wavelength connected with the transition. 1 by lambda is equal to RZ square into 1 by n1 square minus 1 by n2 square. So now what we have got the formula, 1 by lambda is equal to RZ square into 1 by n1 square minus 1 by n2 square. This is the formula we observed here. Fine. And what we know is there is a formula called again connecting lambda and the term mu bar. What is this mu bar? Mu bar is wave number. Mu bar is called as wave number. Wave number is reciprocal of wavelength. So I can write here mu bar is equal to now RZ square into 1 by n1 square minus 1 by n2 square. Mu bar is called as wave number. These are the different forms we have written here. If you notice from starting here, first I have written the energy form as delta E is equal to what I got. Delta E is equal to RCH z square into 1 by n1 square minus 1 by n2 square. From here delta equal to h mu I have taken, I constructed, and I got the frequency formula. Frequency of radiation is RC z square into 1 by n1 square minus 1 by n2 square. In the place of delta E, substituted h mu, I got mu value. Next, yes, now here what happened? Mu is equal to, I got RC z square into 1 by n1 square minus 1 by n2 square. So we know that mu is C by lambda. So in the place of mu, if we replace C by lambda, I got again formula for lambda and Z and N1 and N2. I got this formula. After that, what I did here, I have taken wave number, wave number. So mu bar is equal to, I got RZ square into 1 by N1 square minus 1 by N2 square. Like that, I have got this formula beta. Now, here, one important point when we are discussing this Bohr's theory is, Bohr's theory means we have to discuss about in Bohr's theory, the main part is about hydrogen spectrum. Hydrogen spectrum, it is very important topic here to be discussed. So what is this hydrogen spectrum means? Here we are classifying basing on the wavelengths and everything, the region. We are classifying into categories of Lyman, Balmer, Paschen, Brackett, Fund. Like that we classified into 5 categories here. So here what happened means when we will get this Lyman series, Balmer series, Passion, this is a series we found in hydrogen spectrum. Yeah, so this is actually this Bohr theory is applicable for hydrogen like atoms. So hydrogen atom is perfectly applicable, and any hydrogen like atoms also we can discuss for Bohr theory. Now, series, what type of series means? Lyman series, Balmer series, Paschen series, Brackett series, Fun series. Here, in this series, comes to which type of region? First question is what type of region they comes under each one. Second one is what type of, what is the value of N1 and what is the value of N2. N2, we have to discuss in these things better for all the things here. And one more important point is where we get minimum wavelength, wavelength minimum, and one more important is wavelength maximum, wavelength maximum. What is the conditions for minimum wavelength, maximum wavelength? Here observe carefully beta. When I observe Lyman series, Lyman means it comes under ultraviolet UV region, warmer visible region, Passion near infrared, Brackett middle infrared, middle infrared, and Fun series far infrared. So here the regions where Lyman series we observe in hydrogen spectrum means we observe in ultraviolet region, warmer invisible, Passion near infrared, Brackett middle infrared, Fun far infrared. Here what is the N1 value in Lyman series means 1, and visible, sorry, in Balmer 2, Passion 3, Brackett 4, 5, N1 values. And what about N2 values means here N2 values will start from 2, 3, so on like that. Here N2 value starts from 3, 4, and so on. Here again the year will start from 4, 5, and so on. And again here it starts from 5, 6, so on, N2 values. Here 6, 7, so on. Like that we'll take the values of N2. What is the minimum wavelength? Minimum wavelength when we are observing. So to obtain minimum wavelength, this N2 value, what must be the N2 value to obtain minimum wavelength? What is the N2 value for obtaining maximum wavelength? Maximum wavelength and minimum wavelength. Here minimum wavelength means nothing. N2 value is infinity. N2 value is infinity, then we call it as minimum wavelength. Maximum wavelength means immediate next number. That means immediate next number means here N1 is 1, N1 is 1. So here N2 value is N1 plus 1. So I can write it as 2 here. Here N1 is 2. So here what should I write here? N2 is 3 here. So here again 3 means here 4, 4 means here 5, 5 means here 6. So you observe carefully here. Whenever they told minimum wavelength, all that is the minimum wavelength means N2 values must be infinity. Minimum wavelength also explains frequency maximum. Frequency maximum. Maximum wavelength also says frequency minimum. Maximum wavelength also says frequency minimum. Same topic is there for you in chemistry, atomic structure also in first year. So here again we are telling the maximum is N2 value here 2 for Lyman. That means immediate next number. Immediate next number wavelength will be maximum. Frequency will be minimum. So here N1 is 1 means immediate next number 2. N1 is 2, immediate next number 3. And here 3, 4, 4, 5, 6 like that. Let us observe this one here now in this way. So the first one is N1 is equal to N value is N1 is equal to N is equal to 1. Here 1, N value is here. Let us take it as 1. Next 2, N is equal to 2. Next n is equal to 3, next n equal to 4, n equal to 5, n equal to 6, like that. So n is equal to here 1, like that. We'll take all the n values here. N values means here this is 1, this is 2, this is 3, this one is 4, this one is 5, and this one is 6. So here Lyman means we can have the transaction like that till where we have means infinity. Like that we have till infinity. Here n is equal to infinity. So the coming from 2 to 1 or 3 to 2 or 4 to 2 or 5 to 2, 5 to 1. They are all coming from 2 to 1, 3 to 1 or 4 to 1. Like that they are coming. This series is called as Lyman. And they are coming from 3 to 2, 4 to 2 and 5 to 2 and 6 to 2. Like that they are coming. This series is called Balmer. Lyman Balmer. Like that. Passion, bracket, fund. If passion means 4 to 3 and 5 to 3, like that they are getting 6 to 3. We call this as passion. Passion. And bracket means we can take from where to where. That is 4 to 5 to 4, 6 to 4. From infinity they can come. This is about bracket. And suppose they are coming from 6 to 5, 6 to 5, and infinity to 5, like that. Anything above 6. This is called as fund series. Fund series. So Lyman, Balmer series, passion, bracket, fund. Like that we explain in this way also. So this is about hydrogen spectrum, and how to handle with that formula. I think you understood. And one more important is number of electrons. Number of electrons accommodate in a shell. Number of electrons accommodate in a shell. In a shell, what we can write? Accommodate in a shell is equal to 2n square. 2n square is nothing but number of electrons accommodate in a shell. So now, if the transition takes place, electron jumps from electron is jumping from, it is jumping from where to where. Let us observe, jumping from n shell to ground shell, n shell to ground shell, n shell to ground shell. What is the formula here means? Electron is jumping from n shell to ground shell. The question is number of spectral lines. Number of spectral lines obtained. Number of spectral lines obtained means I can write the formula n into here n into n plus n minus 1, n into n minus 1 by 2. Number of spectral lines obtained when an electron jumps from nth orbit to ground or n shell to ground shell. Suppose electron they didn't told n shell to ground, they told some fourth shell to third shell or fifth shell to second shell, like that. Electron jumps from n2 shell to n1 shell, n2 shell to n1 shell. Maybe n1 can be ground or may not be ground, we don't know. Then number of spectral lines observed, number of spectral lines we can observe is equal to the formula is n2 minus n1 into, I think space will not sufficient. Let me rub this one and write again. n2 minus n1 into N2 minus N1 plus 1, N2 minus N1 into N2 minus N1 plus 1 by, here we can write in the denominator. Just check here once. What is the formula we can write? Suppose you have taken 2 into here n is equal to, suppose second shell. First you observe this one here. Second shell to first shell it is coming. Second shell to first shell. Here I have taken 2. Here 2 minus 1, 1. 2 by 2 will get 1. Suppose you have taken here 3. 3 here. 3 from third shell to ground shell. Third shell to n is number of shells. Number of shells. So third shell to ground shell. So 3 into 3 minus 1. 3 into 2, that means we'll get total 3 here. Like that, here what will be the formula we can write? What is the formula we can write? N2 minus N1. Suppose this is 3 and 1. 3 minus 1, 2. Here 3 minus 1. 3 minus 1, 2 plus 1, 3. Again by, here in the denominator, we have to write what? 2. So N2 minus N1 into N2 minus N1 plus 1 by 2. We have to write number of spectral lines when electron jumps from N2 shell to N1 shell. So this formula, first formula is definitely from N shell to ground shell only, N shell to ground shell. But this formula is not like that, N2 shell to some N1 shell. N1 can be ground or may not be ground. Then we have to use this formula. May not be ground, then you can use this formula. I hope it is clear now. So this is about the Bohr's theory, basic applications, what we have here. These all are applications. What we discussed, just I'll give the rough idea. In today's class, the first page is energy of electron in nth orbit is minus RCH z square by n square. From here, again energy of electron jumps from one orbit to another orbit. Difference in energy levels is E2 minus E1. After that, we have written that one as E1 is equal to minus RCH z square and 1 square. E2 means minus RCH z square and 2 square. By substituting energy formula, we got delta E is RCH z square into 1 by n1 square minus 1 by n2 square. Then we discussed that delta E is equal to, what we did is delta E is equal to, we have did it as h mu. We have taken delta E as h mu and we got the frequency formula. We got the frequency formula like this. After that, I have taken frequency is equal to C by lambda. C by lambda, mu equal to C by lambda. I substituted. I got the formula connecting with wavelength and the transition. Next, I did here that a wavelength 1 by lambda is also called as wave number. 1 by lambda is also called as wave number. So this is the wave number formula. After this information, here hydrogen spectrum is started. Hydrogen spectrum. Here Lyman spectrum, Balmer, Passion, bracket, fun. Lyman means it comes to UV region. Balmer visible, Passion near infrared, bracket middle infrared, fund far infrared. Don't call it as P fund. Simply you have to call fund. Far infrared. Here 5, 4, 3, 2, 1 are N1 values. N2 values. N2 values are, that is after 1, 2, 3, so on. For Balmer, 3, 4, so on. For Passion, 4, 5, so on. Bracket 5, 6, so on. 6, 7, so on. Wavelength minimum. This is also called as limit of series. Limit of series. Limit of series. They told limit of Lyman series. Limit of Lyman series. N1 is 1. N2 is infinity. Limit of Balmer series. N1 is 2. N2 is infinity. Limit of Passion series, N1 is 3, N2 is infinity. Limit of bracket, N1 is 4, N2 is infinity. Fund, N1 is 5, N2 is infinity. So like that we can tell they use the limit or minimum wavelength. Limit or minimum wavelength, you handle the objectives like that. Then they told wavelength maximum wavelength or minimum frequency. Sometimes also they use the term minimum frequency because wavelength and frequency are reciprocal. So here immediate next number. So Lyman means here we have 1. So here it is 2. here it is 2, here it is 3, here 3, here 4, here 4, here 5, here 5 means here 6. Any doubts you can ask better. So this is about hydrogen spectrum base. What I discussed till now is finally the transitions we can represent in the graph like this. That means n1, n2, n3, n4, n5, n6 till n equal to infinity. We can write like this. Lyman, you can observe Lyman, Balmer, passion, bracket, fun. Next, here number of electrons accommodate in a shell means 2n square, 2n square. N is number of orbit, n is number of orbit. Here first orbit 2 into 1 square like that. Electron jumps from n shell to ground shell, n shell to ground shell. The number of spectral lines are n into n minus 1 by 2. Electron jumps from n2 shell to n1 shell. Number of spectral lines are n2 minus n1 into n2 minus n1 plus 1 by 2. Like that I can write. And one more thing, what we have to remember, one more information is about time period of electron revolving around the nucleus. Time period of electron revolving around the nucleus. This is Vn is speed of electron revolving around the nucleus. Rn is radius of the electron in nth orbit. So time period means, we know the time period means distance by speed. Distance means in circle 2 pi Rn by Vn. So this is time period of electron in the nth orbit. Time period of electron in nth orbit, So in nth orbit is represented by T suffix n. Here now we can write from this information Tn is proportional to Rn by Vn. In last class we discussed radius of nth orbit is proportional to n square by z. Speed is proportional to z by n. These things we discussed in our last class when I thought about Bohr's theory. So from that information, now I can write Tn is proportional to n square by z by n square by z by z by n. So from here I got the formula Tn is proportional to n cube by z square, n cube by z square. This is the formula for time period of electron in nth orbit. That is the major information about Bohr's theory beta. I hope this topic is clear. So the next topic will continue in our next class. Any doubts are there, you can inform me. Thank you everyone.